Welcome to Understand All. I'm your host, Aslakir Gareleaf, and today we're embarking on a thrilling journey into the heart of our sun, exploring the captivating phenomenon known as coronal mass ejections, or CMEs for short. Picture this: a solar explosion so immense it could swallow 20 million Empire State Buildings in one cosmic gulp. That's the sheer scale of a CME. But what exactly are these mind-boggling events? CMEs are enormous eruptions of plasma and magnetic fields from the sun's corona, its outermost atmosphere. They can contain up to 10 billion tons of solar material, according to NASA. That's like hurling the weight of 200,000 Titanics into space. But the sun's explosive nature isn't just about size. It's also about speed. CMEs can travel at mind-boggling velocities, reaching up to 3,000 kilometers per second. To put that into perspective, at that speed, you could travel from Earth to the moon in under 2 hours. It's like the solar system's version of a cosmic bullet train. Now, you might be wondering, what causes these incredible eruptions? Well, the sun is a bit like a cosmic pressure cooker, always ready to blow its lid. The culprits behind CMEs are the sun's powerful magnetic fields. As these fields twist and tangle, they can create areas of instability, like a rubber band stretched to its limit. When the tension becomes too much, snap. A CME bursts forth, releasing a tidal wave of solar material into the cosmos. But here's the thing: CMEs are invisible to the naked eye. So, how do we even know they exist? Enter our cosmic detectives, the solar observatories. Spacecraft like SOHO, the Solar and Heliospheric Observatory, and SDO, the Solar Dynamics Observatory, act as our eyes in the sky. They use special instruments called coronagraphs to block out the sun's bright surface, allowing us to see the faint corona and any CMEs that might be lurking there. In fact, the first CME ever observed was captured by a coronagraph aboard NASA's 7th Orbiting Solar Observatory in 1971. It was like catching a cosmic ghost on camera. Since then, we've come a long way in understanding these enigmatic events. But why should we care about CMEs? Well, for one, they're not just cosmic spectacles. They can have very real effects on our planet. When a CME slams into Earth's magnetic field, it can trigger geomagnetic storms. These cosmic tempests can cause auroras, those mesmerizing light shows in the sky. But they're not all pretty lights. Geomagnetic storms can also wreak havoc on our technology. According to a study by the National Academy of Sciences, a severe geomagnetic storm could cause economic losses of up to $2 trillion in the first year alone, with recovery taking up to a decade. That's a hefty price tag for a solar tantrum. CMEs can disrupt power grids, causing widespread blackouts. They can interfere with satellite communications, GPS navigation, and even pose risks to astronauts in space. In fact, a CME can cause your GPS to go haywire, making your navigation app think you're in the middle of nowhere when you're just trying to find the nearest coffee shop. But it's not all doom and gloom. By studying CMEs, we're learning how to predict and prepare for their effects. Space weather forecasters, like those at NOAA's Space Weather Prediction Center, are like cosmic meteorologists. They use data from solar observatories to forecast when a CME might be heading our way, giving us time to take precautions and protect our technology. Predicting CMEs is a bit like trying to forecast when your moody friend might have an outburst. You look for warning signs, like increased solar activity or changes in the sun's magnetic fields. But just like with your unpredictable friend, sometimes a CME can catch us by surprise. CMEs don't just affect Earth, though. They can impact the entire solar system. As they travel through space, they can interact with other planets, moons, and even spacecraft. In fact, CMEs are so powerful, they can even affect the boundaries of our solar system, the heliopause, where the sun's influence ends and interstellar space begins. And here's a thought to ponder. Could a CME be the reason we haven't heard from any alien civilizations? A powerful enough CME could potentially disrupt an extraterrestrial society's technology, making it difficult for them to communicate with us. It's a bit like the cosmic version of "the dog ate my homework," except instead of a dog, it's a giant plasma explosion from the sun. But CMEs aren't just a cosmic inconvenience. They also offer us a glimpse into the fundamental workings of our star and the universe as a whole. By studying these events, we're not just learning how to protect ourselves. We're also unraveling the mysteries of solar physics and the complex dance of magnetic fields and plasma that shape our cosmic neighborhood. And that's where the future of CME research comes in. Scientists are working on new ways to predict and mitigate the effects of these solar outbursts. From advanced warning systems to more resilient technology, we're finding ways to weather the solar storms. But the most exciting part? By understanding CMEs, we're not just protecting Earth. We're also paving the way for future space exploration. As we venture further into the cosmos, knowledge of space weather will be crucial for keeping our astronauts and spacecraft safe. So the next time you see the colorful dance of an aurora in the night sky, take a moment to appreciate the incredible journey of the CME behind it. From its explosive birth on the sun to its far-reaching effects on Earth and beyond, a CME is a testament to the raw power and beauty of our cosmic neighborhood. And who knows, maybe one day, our understanding of CMEs will help us connect with a distant civilization, one solar outburst at a time. In the end, studying coronal mass ejections is about more than just science. It's about our relationship with the star that gives us life and the cosmos we call home. It's a reminder that even in the face of cosmic adversity, we have the power to learn, adapt, and reach for the stars. And that, my fellow cosmic explorers, is the incredible story of coronal mass ejections. From their explosive origins to their far-reaching impacts, these solar behemoths never cease to amaze and inspire us. So, until next time, keep your eyes to the sky and your minds open to the wonders of the universe. Because who knows what cosmic mysteries will unravel together on the next episode of Understand All. I'm your host, Aslakir Gerleaf, signing off.